Okay, hello everybody. Thank you for joining us. I suggest we could start just a second. We could start now with our webinar. First, a couple of words from me, and then I'll give the word to our guest today. If you don't know where you are, you're joining our webinar. We are Sofia Revit User Group, and we just a second, and we are organizing this event to bring some international experience and knowledge to our local group here in Bulgaria, and that's why you'll see what you're gonna see. Just a quick reminder about how you could know more about us. This is our website, so you could find us on sofiarug.com. I hope you are seeing my screen right now. And this is our website where you could find information about our past events. And if you, for example, open one of the events, you could find more information about it, and of course the recordings, which are important for us as well, because not everybody could be on the live event, so there are recordings, and you could check our YouTube channel where this webinar also will be uploaded, so you'll be able to access the information later. The only thing that I could add here is that if you want to support us, you could become our partner. And if you want to be our partner, please contact us from this contact form. And you could find here us on this email or on the following these links on Facebook, LinkedIn, or any other way. Of course, we're also on Patreon, so you could visit our Patreon page and support us here as well. So I'll stop sharing my screen and give the word to Gavin, who will introduce himself and tell more about pyREVIT and automation and other very interesting topics.
Great. Thank you, Peter. I'm really looking forward to presenting to this group. I haven't presented to a group, I believe, from Bulgaria before, so it's a new audience for me, which is great. But it's also nice to just meet other people that probably are doing very similar things in different areas of the world. We probably have the same challenges, the same opportunities, different markets, different opportunities, of course, but I'm sure we're all here for the same reason, which is that we're very passionate about BIM. So I'll just share my screen and jump right in. But today I want to present about pyREVIT. So this is a tool that I've really enjoyed starting to really implement in practice. So today I was going to really cover some of the fundamentals, why I think pyREVIT is really valuable, how I see it as an alternative to Dynamo or an addition to Dynamo, which I'm sure most of us are probably quite familiar with already. And then actually show you some toolbars, some tools I've developed myself. I'll show you the toolbar that we use at Architectus, the firm that I work at. And finally, we'll actually build a basic tool in pyREVIT as well. So unlocking the power of pyREVIT. Of course, firstly, thank you to Peter for inviting me to present today. I'm always happy to present to groups like this around the world. So if there are other people watching with user groups, feel free to get in touch and I'll definitely consider if there's time to present. But I've had Peter on my network for a while, so recognized him straight away and was more than happy to present today. Thank you to Sofia Revit User Group for hosting me today, and of course also for providing a place for people to come together with common interests. So if you haven't heard of me before, my name is Gavin Crump. I've been working in AEC for almost 11 years now. I'm currently living in Adelaide in Australia, which is down to the south. It's my hometown. I did work in Sydney for about 8 years, where I really grew my career quite significantly and moved back recently. So I have an architectural background. I did study as an architect and realized quite early in my career that I was more passionate about BIM and how it applies to architecture. But I bring with me a background in understanding how project delivery works for architects, how we coordinate the priorities that we have and the ways that we need to interact with our software. So I've worked at most levels of BIM, coordinator, manager, technician, consultant. So I have a pretty broad appreciation for not just the software, but the process behind how we work. I'm currently working with Architectus, probably the largest firm in Australia for architecture, probably the largest by headcount and probably also by sector coverage. So it's a really great opportunity for me. But in my spare time, I do produce videos on my YouTube channel, the Aussie BIM guRoo, which probably a lot of you probably have found me through in the past. So Architectus, we were about a 400-person firm. We recently merged with another firm that I believe is 250 people, Cronin & Gargett. So we're about 650 people, I believe, at the moment. So a fairly big firm, so quite a lot of opportunities to deploy solutions and tools at scale, which is really what attracted me to working with the company. So we cover pretty much all sectors in the market now, but we do have a specialist BIM department in-house with about 20 of us that all work together to manage the BIM of this 650-person company. It's a really interesting opportunity. It means that I work with a lot of similar people like me, which is, again, really what led me to actually work for this company. I did join in June 2022 on a part-time basis and went full-time about 2 weeks ago. So this is pretty much my full-time role now. I do work with mostly computation and automation in typically the Revit and Rhino platforms, and occasionally in other platforms that might work interoperably with them, and typically focusing on the design and delivery workflows. I did BIM consult for a few years, but did realize that it was going to be difficult to scale this opportunity. So I have since stepped this back into a focus on providing Revit templating and content management solutions, and focusing on also course production, hopefully in the future. I do have a couple of free BIM models over on my platform, one that I'll use today, which is the basic sample project, but built a little bit better than the standard one. So if you want a free, good quality Revit model, feel free to jump on over. I also have a Dynamo course. If you're looking to get started with Dynamo, this might be a good resource for you. It really teaches you from start to finish how to become an intermediate user. There's quite a lot of content in there for $50 for 1 month or $200 for unlimited, but usually most people can knock it down in a month. In my spare time, I make 1 video per week as the Aussie BIM guRoo. I started this in 2019 because I recognized that there was a gap in the industry when it came to knowledge sharing, particularly at a firm level. There wasn't really a lot of sharing of workflows that were at a level that really suited professional practice. Most of the YouTube channels I saw were typically producing student quality workflows, which is fine if you're a student, not so good if you're not. So I really wanted to start distributing professional workflows that you could take to put into practice in your company straight away. Focused on Revit and Dynamo originally, but have branched out into Grasshopper and Rhino, and also pyREVIT and Python. So I focus on what I would see as everyday scenarios you might run into in automating typically the Revit platform, but also more recently the Rhino platform. Currently 35,000 subscribers, which isn't much if you're a big YouTuber, but not bad if you're in BIM, and about 350 videos at the moment. So if you haven't found my channel, feel free to check it out. It's all free. There's a couple of ads on there, but I don't really make a lot of money from it. It's just because YouTube put ads on there before anyway. So I thought, well, I may as well be the one making the money, not YouTube. So anyway, today I'll be focusing on pyREVIT. We'll talk about what it is, how you set it up, but I'll begin by looking at automation and Dynamo in general, because I know a lot of people still aren't really programming at the moment and maybe are curious to learn more about that. I'll then look at Python as a programming language and how you can learn the basics, and then apply it in pyREVIT and show some toolbars in action. So for those that haven't seen this motto from Autodesk, they're telling us that we shouldn't be waiting for them. Don't wait for progress, make it. They've given us some tools that we can use to develop our own custom solutions. And it's becoming quite clear to most people that use Revit that not every feature is going to come anytime soon. If we stand and wait for things to change, we're going to be waiting for quite a while. So we may as well take advantage of the systems and automation opportunities that are available to us. So programming to me is a really great solution to some of the problems in the software that we use, or the fact that a lot of the process that architectural firms use isn't always captured in the tools. It's a great way for us to capture our process, our workflows, and make sure that our software can work with other pieces of software. Sometimes programs that aren't really designed to work together can still be customized to support a broader ecosystem of software. It allows us to collaborate more openly. We can use things like GitHub in order to share code amongst people, sometimes inside companies, sometimes outside companies. And we can solve a lot of really what I see very boring problems, things that people aren't really wanting to do for a career. Things like putting revisions on sheets. Like, who went to university to do that? No one. So you may as well find better ways to do it. Take out the boring work, and then we have more time to do what we actually want to do, which is architecture, engineering, construction, design, high value things that a company actually makes money from. So whilst programming isn't the only way to solve these problems, it's a really great way. It's a real challenge though. Not everyone is a programmer at heart, but we have more in common with programmers than we probably think. The way that we think and the way that we design is often similar to how a programmer would solve a problem using code. And over time, you may find that you actually relate to programming quite deeply, as I have found. I didn't learn to code at university. No one really taught me directly. I just started exploring the field and started learning over time. There's a lot of resources out there you can learn from, and a lot of them I found. But at the same time, I think the best way to learn to program is really to explore the field, to get deeper and deeper as you go. And eventually you'll find the things that really excite you and make it more interesting overall as a profession. There are challenges that come with it. You need to change the way that you think sometimes. There are a lot of questions around intellectual property and who owns code, who owns process. We've went through similar challenges with Revit. Who owns the families? Can you send a model to someone? It's not really too different. Most of the time, it's hard to protect a lot of things unless you write code in a very particular way, but that can be a lot of effort. So sometimes companies need to decide which areas of their company actually need higher levels of protection than others. And often some of the programming companies produce, they don't protect that significantly because the risk of losing the information is quite low. At the same time, we also have to question what makes a business make money. Is it a tool? Maybe not. Is it how you use the tool, how you train people to use the tool, and the people you hire to use those tools? Yes, much more likely. The service that we deliver is often not really about the tools we use, but how we apply them. And programming is a great way to reinforce that. If we can overcome these barriers, companies can make a significant amount of improvement to their workflows and to their value that they return to their clients. A lot of people do say, I didn't become an architect to learn programming. Sure, but you didn't become an architect to do a lot of these things that you do anyway, right? You didn't become an architect to produce sheets in Revit all day. There's a lot of things that we still do that we don't have to do. So I always tell people, get a computer to do what you don't want to do that it can do well. You can make excuses all day. At the end of the day, the person next to you is going to learn to program anyway, so why not try it out? You might like it. Everyone's waiting for the magic button that fixes everything. It doesn't exist, but you can build one. So Dynamo is a great app that came along, I think in 2012, roughly, a visual programming platform, which is a much easier way to learn to program because you can visually see how the programs are functioning. It's open source, although it has been integrated into programs that aren't open source, such as Revit, and developed in certain capacities that maybe couldn't be seen as open source. Originally invented by Ian Keogh and acquired by Autodesk, at least for use in the purpose of Revit. Now Ian's more focused on Hyper, a web-based platform that is definitely worth checking out. Most of us here have probably heard of it, probably used it, might be experts in it. It's pretty rare that people in AEC haven't heard of this by now. So what is Dynamo? How's it working? Well, this becomes quite important when you start looking at things like pyREVIT. It's important to understand how Revit is built, how its code comes together, and how we can talk to Revit using automation. So Dynamo is built to communicate to Revit using what's called an API, an application programming interface, and it uses DLL files, which are basically like books of instructions that we can use to tell Revit to do things. These have been given to us by Autodesk. The people writing the software have exposed these to us as ways that we can talk to Revit. We're not necessarily inside the core of the program. That's typically not how you can work with a piece of software, but we're at a layer above that where we can tell the program to do things and automate processes. There are also Python wrappers or a Python shell built into Revit that mean you can also use Python to communicate with Dynamo and with Revit as a connection through Dynamo to access these APIs as well. Dynamo is really great because it's actually opened up the community a lot more. A lot of programmers come to forums, they have user groups, and because companies really don't worry too much about the value of programming as a concept, it gives people the opportunity to really start to share their ideas and their opportunities. And sometimes companies can learn from each other. And Dynamo has been a really good way to share ideas in an actual object, a script, but also an idea. So I found it's been a really big change in the industry, for me at least. I've noticed that people are becoming much more open with how they communicate and how they present what their companies are doing. If not for Dynamo, I reckon I probably would have left the industry. Some people I've spoken to have said the same thing, because programming has really enabled me to be a lot more efficient, but also has given me a passion for helping other people be more efficient, which is sort of why I got into BIM management in the first place. I liked helping people, and programming is just a stronger way, I feel, to help people use software. So whilst you could build good families, you can also take away processes that waste people's time. So it's a really great way, I find, to return a lot of value to the companies you work for and also to the industry at a higher level. So thanks, Anne. So I'll quickly just have a look at a Dynamo script. If someone hasn't seen a Dynamo script before, I think it's worth actually showing one, what it does, and sort of some of the limitations that come with it, but also some opportunities that they provide. So this is the model from my website. So if you want one, this is it. It's got documentation in it. It's got drawings, and it's not like the Autodesk model. It's a little bit neater. It's got some room layout sheets, and it's a bit nicer than the standard one, and it works in Enscape. But anyway, so I'm going to open up just a Dynamo script that I've built earlier, and it's made to automate placing revisions on sheets. So if people might recognize this workflow. Let's say you have a new revision you create. We're sending out a drawing set. We call it whatever we call it. I'm going to revision them. I'm going to go down, pick the revision, add the revision, pick the revision, add the revision. And I'm sure all of us have done that in Revit at some point. It's really boring. It's a big waste of time. And back in the day, I used to do that for hundreds of sheets at a time. And it would take a good hour to get a sheet set ready to print. This is like 12 years ago, when Dynamo wasn't even really a thing that was available to us. Let's automate that, because that's really boring. So this is a script that can automate that process. Now, Dynamo can be complex when you build scripts to be user-friendly. This whole part of the script here is just to build a user interface to take some inputs from the model that the user can pick from. This is using a custom package called data shapes, which enables you to create a form using various inputs, such as a dropdown for picking a revision, a list view for picking a set of sheets, and a combo button, or just a choose an option button, which lets us either add or remove. Finally, we take our inputs and we use them to process whether we're adding or removing revisions. It's important to note these are custom nodes. You'll notice this script is mostly using custom nodes, because at a certain point in Dynamo, you'll find there are things you need Dynamo to do that by default, it doesn't come with the possibility to do unless you actually write your own code in Python or C#. So this, for example, is a custom node that uses Python in order to execute some Revit API. So this obviously isn't an entry point to programming. This would be once you've used Dynamo for a while and you're comfortable learning more about the programming of Revit. But at the surface level, for a basic user, you might be able to work with this. So we use custom packages in order to capture these functions. So this is Crumple, a Dynamo package that I develop in my spare time. Finally, at the end, we count what's happened and we build a little message for the user. So when I hit run, it's going to bring up my user interface. From this, I can pick my revision, set 2. I can pick the sheets that I want to revision, run it, and I've just added the revision to 20 sheets. Now, one of the really cool things about programming is that that is just 20 sheets, but there's no reason that can't be 1,000 sheets, 5,000, 10,000. The point is that I've got a process and I can send objects to the process, run the process, and it scales. Now, code doesn't always scale well. Sometimes it gets slower, sometimes it crashes. So it's not perfect, but at the same time, there isn't really a limit when you build your tools well. So Dynamo really helped me find a way to scale my processes rather than relying on manual workflows and people having to do very boring tasks. Because when we're bored, we make mistakes. There are some pretty big limitations with Dynamo. It's not perfect. Nothing is perfect. No tool is perfect. Some of these problems come from it being a visual programming platform. It's not really Dynamo's fault. Dynamo is not built to be the final program you use to build all your code. Having said that, it can do a lot of things really well. Some people find Dynamo does everything that they need it to do, and that's great. I've sometimes criticized Dynamo in the past, but having thought about it more, I've come to realize that it's still an amazing tool for helping people find out about programming, about the Revit API, and eventually may lead people to other avenues such as pyREVIT or C#. I wouldn't have found these without Dynamo. So one challenge that Dynamo does have is you will become dependent on custom packages quite quickly, especially if you want to do more complicated workflows. For example, adding revisions to sheets isn't something that Dynamo currently has as a node as it comes out of the box. You have to usually find a package that is able to do this. And once you take that script to another computer, they're going to have the same package as well in order to run your tool. It's a pretty big limitation, but it's one that you can build around using IT, of course. You can deploy those packages around the company. There's various ways to solve it. As well as that, deploying scripts is just challenging as well. There are various considerations such as, is the computer going to be set up in a way that lets the tool run exactly the same way? Is the model ready to have this tool used on it? Not every tool will suit every model. It depends how you've built it. You might build a script that works really well on a tiny project, but it crashes a big project. So you have to be careful with how you develop your tools. As well as this, Dynamo isn't great at what I call control flow, where you can tell the script to do certain things under certain conditions. Typically, visual programming goes from left to right, top to bottom. It usually goes in one direction, and usually most of the code in there is going to have to run at some point. So it's quite difficult to set up conditional statements. It's sort of possible, sort of not. You can't say, if this, then do half the graph, otherwise do the other half of the graph. You can send nothing into one side of the graph and get the other side to run, but it's a very big and clunky way to write that sort of code. As well as this, typically the script has to finish. You can't say, get halfway, oh no, there's an error, stop. It's going to keep going all the way to the end. So you've got to catch errors. You've got to know how your scripts are going to fail, and you're going to have to build them in a very particular way to deal with that. Otherwise, you'll get errors. You might crash. You might go into an infinite loop. So there's a lot of challenges that come with that. As well as this, Dynamo Player is a tool we can use to deploy scripts, but it's also one of the only ways you can really deliver Dynamo out of the box to users. There are some ways to fix this. There's some programs such as Orchestra, Nonica, Relay, I don't believe Dyno is running anymore, that try to solve these problems by enabling you to deploy packages through the cloud or to put your tools onto ribbons in Revit, where you run Dynamo behind the scenes instead. But Dynamo is really just the tip of the iceberg with programming. It's enough to get you started, to get you interested, and to help you automate some workflows. But to me, there's a really big world of programming out there. And once you're ready, it's well worth looking into it. So you can see this isn't probably the best representation of the size of languages. This diagram's a couple of years old, but Python is definitely still a pretty major bubble in here. I would say C# is probably a little bit bigger if you just look at AEC, because C# is quite big because of Revit and Rhino. There's many ways to learn beyond Dynamo. There's really going to be three key things for Revit that you'll need to tackle at some point. One is probably Python, because most people will go through Python at some point. The Revit API, which is the language we need to use to talk to Revit, and also add-ins, C#, and also the Forge platform. But it's more important to figure this out first. What is your goal? What do you want to do? Why are you programming? What's the point? You've got to figure that out first. Otherwise, you're just going to spend heaps of time here and just go around in circles. Most people that come to me say, how can I learn to program in Revit? And I say, first of all, figure out why you want to program in Revit, and then you can go back and see what you actually need to do in order to reach your destination. So you might take a scripted pathway. This is sort of my pathway. So I've learned the Revit API, I'm applying it to Python, and I'm mostly building for automation, for fun, for my firm, for Dynamo and pyREVIT. Maybe you know a little bit about C# already. Maybe you've got a background in computer science. Maybe you might just be able to go straight to C# and develop add-ins. This is great if you want to make profit from your tools and protect them. You can also have fun, of course. It's always fun. You might be able to develop add-ins for a firm. You might be able to use the Forge platform to automate BIM 360. Or maybe you take the hybrid pathway. Start easy and work your way towards here. Eventually, this is probably the pathway I'm taking. I'm still not quite sure if C#'s for me, but we'll figure it out. At some point, you have to bite the bullet and go to written programming. There are a lot of valuable things that written programming enables you to do. They're not always obvious at first. When I first saw written programming, I said, wow, that looks so hard. It looks so inefficient. How do I track what's going on? But it's like learning a language. Eventually, you start to recognize things quite easily. You start to recognize patterns, sequences, naming syntaxes. There are some really powerful things that written language gives us access to. First of all, it allows us to iterate. We can tell something to go over and over and over again until it runs out of things to do. This is a very powerful thing. We call it looping as a nickname typically, but if we have a list of objects, we run a process across those objects. And the reason why this is typically more powerful than visual coding is because we can capture that inside the loop. We can do a lot of things in a loop. So here, we're doing something for something in a set of users, and you can see we're able to execute a lot of code across a list of objects, and we can put lots of conditions, things that we're checking in there, and it's all captured inside that process. Whereas in Dynamo, we'd have to do that all inside one node across a set of objects. It's a lot easier to reference objects using variables, so we can call on objects very easily. We don't need to take a big wire across half of the graph just to grab some data from before. We can just reference the name of a variable instead. We can also transform objects. We can take an object, do something to it, and in the computer's database, that object is still the same object. We're referencing something that's had an action applied to it, but we can still keep referencing that object from before. There's control flow. We can catch errors. We can do things when errors are detected using various statements, which is really powerful. So our code doesn't have to fail if we know there's a chance it could fail. We can actually build exceptions to try and catch those scenarios. You can access APIs more directly or libraries in order to access a vast library of methods, functions, classes, things that really allow you to expand your code without too much dependency on custom packages or libraries. As well as this, over time, it might not look like it at first, but this does become easier to read. I actually find it easier to read written code than visual code these days, mainly because visual code does get quite messy a lot of the time, whereas usually it's easier to understand the logic someone's trying to go through, often because people put comments on their code too, which really helps, whereas visual coders don't typically comment, I found, so that can really help as well. But over time, I see picking up a written language is the natural next step from learning Dynamo to escape the nodes. The Revit API is really Autodesk's gift to us to let us automate Revit. So it's a bunch of commands that have been compiled, which we can access and send to Revit in order to automate tasks. Now, not everything in Revit is captured in the API. Revit was written quite a long time ago from its foundation, and the API wasn't an initiative that they started on day one. In fact, I think back then, giving access to an API wasn't that normal. Now it's normal for today's software programming to build an API for the users as you go, but back then probably not so normal. So some things that are really old or haven't been rebuilt in Revit for a long time aren't necessarily automatable. For example, keynotes, there's very little access to the keynoting system using the Revit API, but there are lots of things still available to us. This is, in my opinion, the hardest part of learning pyREVIT, Python, and C# for Dynamo is actually learning the Revit API. It's the thing that I encourage people to focus on the most when they first begin. Learn the fundamentals of the Python or the C# platform, or Visual Studio being the platform in the case of C#, typically. But learn the fundamentals, but then try to really understand how the API works. There's a really great website, Revit API Docs. It's actually one of the better API websites, in my opinion, out there at the moment. Not everyone would expect it to be one of the better ones, but I think it is. It's got great documentation on what we call the classes of the API. For example, walls have their own dedicated class. We then have various methods, properties, and enumerated properties that we can apply to either methods or other properties. And also, we can see some examples of Python and C# on the API docs as well. It's not always going to tell you the Python syntax for things, but it's not usually too different from the C# approach, with a few exceptions. So Python, in my opinion, is a really great versatile programming language. It's probably one of the fastest growing and one of the most popular languages. It's not necessarily the most efficient language at talking to a computer, but it's a very easy language to pick up for a person, in my opinion. It can do a lot, and it's being expanded upon. There are other dialects of Python, wrappers of Python, different ways of writing Python. You might have heard of IronPython or CPython, different wrappers that have different ways of working. Some of them are made to talk to a computer more efficiently. Other ones are made to be more accessible or to work with a particular program. So Python, programming language, fast growing, great for beginners. In my opinion, it's very easy to read and also very easy to write, as long as you write it well. You can write Python code very badly, and of course it's hard to read, but just like any programming language, you learn good habits over time. I think it has vast potential. If your destination is to build the fastest tools possible, I wouldn't say stay with Python. Eventually, you'll probably want to learn C because it is a more direct way to communicate with the memory of a computer. It's more efficient and typically will allow you to build applications and software, whereas Python typically relies on an integration or a wrapper or a shell built into a piece of software to allow it to be run within that actual piece of software. So where can you learn it? Heaps of places. There's a website called the Dynamo Python Primer, which is pretty good. I think that's one of the best places to begin if you're looking at Dynamo specifically. I have a quick series on my YouTube channel, which has helped a lot of people. There are lots of custom packages in Dynamo that have Python exposed in them. For example, Genius Loci is one of my favorites. Of course, my own Crumple is all in Python. The Clockwork package, the Spring Nodes package, they're all very popular, but they all use Python. I'll probably show a few key terms and techniques just to introduce some concepts in Python before we jump into pyREVIT for people that have never seen or used Python before. If you're a Python expert, it might be a little bit boring, so sorry, but I'll try to get through it pretty quickly. So you can use Python in Dynamo, typically in custom packages or custom nodes, usually in Python. If you can access a custom node, you'll know it because you can see these 3 dashes behind the node, which means you can edit the custom node. So let's just do a quick little crash course in Python. I'll try to keep it pretty quick. I've just got to quickly access a file. I'm going to do some live programming, which is always dangerous, but we'll see how we go. Usually live demos go okay for me. So hopefully I haven't tempted the programming gods the wrong way. Okay, so let's just do a little crash course. Here we go. I'm just rearranging my second screen so I can refer to an example. So I'm just going to run it through Dynamo rather than pyREVIT because it's easier to sort of see what happens in Dynamo than it is in pyREVIT typically. Usually if you use Python in pyREVIT, usually you're going to have to print or send your output to a command so you can see what's happening using what's called a console. So I'm just going to create a Python node. By default, I have this thing that we call a boilerplate that will be here by default. I'm going to delete it all, but this is really referencing all the Revit API references that I commonly use in order to actually communicate with Revit, collect the current document and application, a few functions for making sure objects are lists, and then a transaction that I use in order to make changes to the Revit model or the Revit DB. So I'm just going to delete all of this. And I'm just going to connect a watch node to the output so we can see what's happening. So by default, a Python node in Dynamo takes in any number of inputs, including no inputs, and also sends one output. So we've got various things we can store in Python or manage. We can use variables. So I can make a string, which I declare using the equals sign, and I can say string. Currently, nothing will happen in Dynamo. We have to actually send our result out to the out variable. This is quite unique to Dynamo. And I can see now I'm sending out string, and of course it's going to have a data type associated to it. So I can check the type of it, and it's going to be, in this case, a string. I can also do numbers. So let's do an integer being something without what we call a floating point. And we can also do a float, which in this case will have a floating point. We can also do lists. So I can write a list. If you've ever used code blocks in Dynamo, it's the same thing. But what I can do is reference my variables and pass them forward and use them again. And then I can send out my list, and we'll see that we can store a mixture of data types through Python in a list object, which we use quite a lot. We'll use a special type of object now. This is a range. So there are lots of constructors in Python that you learn over time. Let's make a range object, which in this case takes a few arguments, say like 1 to 5 with a step of 1. And then we'll just send that out. let's say we want to do something to the objects in that range. I can see now I've got 1, 2, 3, 4. It ignores the last integer. That's something you learn as well. Lots of things to learn in programming, just like lists start at 0 and all those sorts of things that don't make sense at first, but the more you think about them, the more sense they make. So what we're going to do is use iteration. So I can say for each number in my range, and I'm going to create an empty list. And I'm just going to call this out list, which is a list with nothing in it. I can say that to out list, I want to append, which adds an object to the list, n times n. And this basically passes each object within this list to this line in the loop, and then I can send out the out list. And as I expect, I should get squares of each of those. So you can see that a loop is a pretty simple mechanism, but we can put as much logic inside that loop as we want. It can get quite complicated, as complex as we need it to be. I can also make functions. So I can say define power. I'll just make one called math power, just in case the word is reserved. If there's a word that does something in Python or programming, usually you're not going to want to use that word for something you're creating that's custom. Let's say for my function, I'm passing n and p, which by default is 2. Then I will return. Actually, I might just keep it simple. I'll just do n for now. N times n. So we can also use functions to sort of build almost like little custom libraries within our code. And then I can just pass that function instead. But of course, within that function, we can make that function as complex as we want. We can put it inside the loop. We can do all sorts of things. And let's say maybe we want to check if these values are larger than a certain number, maybe larger than 5. So instead, I'll just say that firstly, our value is power of n. And I'll say if value is greater than 5. And I'll, in this case, say message equals, it's a big number. It's not really that big, but there we go. Else message equals 2. That's not that big. And then finally, again, I can append to out list message. And now I've made an error, of course. List is not callable. My range, value, math power. And this is the most important part of programming, troubleshooting. I think in this case, I'm going to have to append. I need to append it. So that's like what just happened there is about 75% of the time of programming, just fixing problems. But there's a little example of something I missed. But you can see that I got given an error. It sort of told me which line was causing an error in the code. So you can sort of troubleshoot. It tries to help you. But you can see now we've created the conditional outcome from a function within a loop. So we can see we're adding complexity as we go. Let's say that my range has something in it that doesn't really work. Let's instead say that I want to make this number divide by itself. Obviously a bit of a silly thing to do. And if anyone knows mathematics, there's going to be one condition that's going to be a problem here. If you know it, it's going to be dividing by 0. So what happens if my range goes down to 0? I get an error. I attempted to divide by 0. So this is a problem for our code. This would stop our code from functioning. So the last statement I'll show you, which is one of my favorites, is the try statement. So I can try to do this. And if an error is caught, which we can specify the error type if we know what it's going to be, or if we want to catch a few different types of errors, but instead we can just return none or null. Now we can see in this case, there's going to be some issues because some scenarios there are going to trigger, I think, a 0 in this case. But in this case, we can see that an error is not greater than 5. So it's going to catch when that happens anyway. We can also make our statement a little bit longer. We can say if value is less than 6, then it's this. Otherwise, message is equal to error. We should find, I believe, that in this case, I might have to assess my code again. I don't want to spend too long on this, but I think in this case, I must have missed one thing. Generally, there would be a way to get to a point where you catch that final outcome. I won't spend too long on it because I went way outside my example that I wrote down. So I don't have a little cheat sheet for this part, unfortunately, but I'll That's just an example of working with some statements and variables in Python. We haven't used the Revit API at all there, but we will use a little bit in pyREVIT. So let's actually get to what we're here for, pyREVIT. But I wanted to lay down all those steps to get to pyREVIT because that's really the process most people take to reach this point. So pyREVIT, Python for Revit, it's an add-in for Revit, which allows you to access the Revit API and run Python scripts that communicate through the Revit Python shell. You can also run Dynamo scripts through it, which is quite interesting, but I generally just use Dynamo Player for those because it's still an easier method of deploying and setting inputs. From here, you can also detect events in Revit, which is really cool. So you can run these things called hooks that trigger when certain things happen in Revit. For example, you can stop commands from happening. If someone tries to model in place, you can block it. You can say, no, we're not modeling in place today, sorry. Or you can silently just send an email to a BIM manager saying someone just tried to model in place, and you can actually start warning people when things are happening. So if anyone knows Guardian for Revit, an add-in, that's pretty much the way Guardian works. It uses events in the background, but you can do the same thing in pyREVIT. You can put it all into toolbars, which is probably the best part. Easy for users to access and see. There are heaps of tools that come with pyREVIT, and one of the biggest mistakes people make with pyREVIT is that they assume that's all pyREVIT is, and it's like, no, this is just really the tip of the iceberg. You can build your own custom tools. Now, they're all really awesome tools, but the best part about them is they're written in a way where you can see how they were written by the author. It's all open, and you can learn from the way the author writes their tools as well. So Hassan Aran-Najad is the author of pyREVIT, also works on Rhino Inside with McNeil, so he's very busy. But luckily, pyREVIT is open source, so that means other people can contribute and help. For example, there's a guy called Jean who's actually contributed the Revit 2024 installer because Hassan was busy. So the benefit of open source is that the community can support this. It's not like a piece of software that can be abandoned because it's open for anyone to pick up whenever they want to help. Now, at the same time, of course, sometimes no one helps. That's the challenge with open source. Sometimes you won't have the commitment of a paid software base. But at the same time, usually these projects have very passionate users that are drawing value from these tools, which justifies them being used. For example, I donate to the Patreon personally every month because pyREVIT just saves me that much time, that many headaches, makes me that much happier in my day-to-day work. So it solves a lot of things. pyREVIT is quite easy to deploy to users. Custom extensions are very easy to deploy. It's very accessible. It's on a toolbar typically. There's not much dependency on custom packages. There's a lot of things that come with pyREVIT for a Python coder that enable you to do things such as creating user interfaces or accessing mathematics libraries, things that Dynamo doesn't always have as it comes. But you can use a lot of control flow and you can terminate scripts at certain points. It's pretty powerful. It's free, open source, and has a lot of benefits that come with that. How do you deploy it? Well, you can download and install it from the GitHub that pyREVIT is hosted on. There's a few prompts to install it, and you open Revit and it's there in all the versions that support it. If you have any custom toolbars from there, you can load them in as what we call extensions, and I'll show you how we do that in a sec. There's a document website that teaches you about the commands that pyREVIT supports that aren't necessarily just part of the Revit API, but are part of the custom code built into pyREVIT itself. For example, the error swallower lets you suppress warnings using the iFailure processor class in the Revit API. But the author has built their own simpler implementation of this class using what they call the error swallower. There's a developer docs, which has more tutorials. I don't use it as much because I'm more of a programmer. I use the docs a lot more, but this is great for people that just want to learn in a more easy, safe environment than a developer docs. You can run Dynamo scripts, but you're probably going to have to use data shapes to generate user interfaces, or you're going to have to write your own win forms in Python, which is a lot of work. So just be aware, if you do want to use pyREVIT to deploy Dynamo scripts, you're not going to get Dynamo Player as an interface to run your scripts. So you will need to find other ways for the users to provide inputs to the scripts. These are some of the tools that come with pyREVIT. There's quite a lot. There's drop-downs, all sorts of tools hidden in there. Some of them do really weird things, such as storing things to memory and recalling them. And then other things are more useful, such as doing an audit health check or creating hatch patterns, probably one of the favorite tools for most people in pyREVIT. It's actually how a lot of people find pyREVIT. They need to create custom hatch patterns, and pyREVIT's really good at doing that. So the toolbars are built in parts or layers. So we begin with what we call the extension, which holds it all together. It's sort of like an app in some regards. We have a tab, which is this thing you pick in the top ribbon, and typically you can name that whatever you want. Usually that's the name of your extension. And then from there we have panels, so you can have multiple panels that are separated. And finally, you can have push buttons, pull buttons, stacks, all sorts of arrangements of buttons you can click, you can drop down, you can do all sorts of things with. This is actually a part of my custom extension called guRoo, which is based on a kangaroo that I actually distribute via my GitHub for free to hopefully teach people a bit more about pyREVIT. There are some pretty cool tools in there. I haven't just made them all really basic ones. There are some that are quite complicated, so hopefully it's useful. So you actually do this in folders. These are all extension, panel, tab, and buttons. They're all just in folders with a dot to specify what type of thing they are. So it's really easy to build a toolbar. If you know how to use Windows, you can build a toolbar. Whereas it's a lot harder to do that using C#, but sometimes more powerful. There are user interfaces that you can use in pyREVIT that come by default. If anyone's had to build a user interface before using WPF or WinForms, you'll know it's not a quick thing. It can take quite a while to build a good interface. One of the limitations with the forms in pyREVIT is they usually do one thing. It's not like data shapes where you can put all the buttons together and make one big interface. If you want that, you are going to have to build the WPF or Windows interface and probably use the XAML programming language to write your own interface, which takes quite a while. You can also do things that are pretty strange. For example, there's a console you can make appear in pyREVIT, and you can create buttons that you can click on to navigate to objects in the model, and you can keep this window open while you work in Revit. So you can build little reports about the model. You can find CAD objects such as CAD links and views. You can go to the view the CAD objects in. There's all sorts of cool things you can do with that. One of my favorite things is you can stop the script. You can say exit, and the script will just stop wherever you tell it to stop. So if you have half of your code that you don't want to run, you don't have to send it through like Dynamo in an error state. You just exit the script and that's it, it's finished. As well as that, you can store data to your computer and draw upon it later using temporary files called pickles, which is a system that Asan's built into pyREVIT. I find that quite useful, especially when you're storing settings for users. That can be quite handy. And there's a lot more it can do. But I think I'll probably just move on to actually showing it. So we're going to be using filtered element collectors a lot of the time in pyREVIT. These are really us querying Revit to return some objects based on some criteria. So if you've never seen a filtered element collector, it's a class in the API that we apply to a document, and we usually provide methods to it, which specify things about the objects we're looking for. It's sort of like building a filter in Revit. So we're asking for a category. That category is sheets, and we don't want it to be an element type, and we want to cast those to elements. So these are really useful for getting started with a script. There's all sorts of buttons you can support. This is guRoo as it currently looks. So we have things such as what we call stacks, we have pull downs, and we have push buttons. So we can have push buttons in pull downs. We can make smart panels that have pull downs with push buttons in them. You can make a toolbar quite condensed if you want to put lots of tools in it. So as you can see, you can create drop downs, put pull downs in them, push buttons. You get a lot of real estate, and you can do this just using Windows folders. It's not super complicated. These are some examples of hooks that actually I use at work. So I have a "Are you sure you want to model in place" window, where the user is asked whether they want to model in place when they do it, just to make sure. I have a tool that disables that message because people get annoyed by it sometimes, but it's there by default. I also have a sync timer that checks how long the sync went for, so that they can see if they had a bad sync, they might need to talk to their model manager. But you can do all sorts of things with hooks. This is pyREVIT for Architectus. This is my toolbar where I work. So there's about 150 tools buried in there. They load for Revit usually in about 3 to 4 seconds when you open Revit. So users typically won't even know that these are loading in the background when you open Revit. Because one of the biggest criticisms I find of pyREVIT is people say, well, it makes Revit load really slow. Yes, if you put your toolbar on a server, it's going to load as fast as your server can give you that toolbar. If you put it on the local computer for the user, it's pretty much going to load instantaneously. guRoo is my free toolbar, obviously a little bit smaller than the one for Architectus, but I'll show you both. So let's just do a little crash course in making a tool in pyREVIT. So we're just going to build a tool that will either make a sheet name uppercase or lowercase. Obviously a really simple thing, but from this you can obviously build upon the logic that we cover. So I'm just going to go straight into Revit. And in pyREVIT, under its settings, I'm currently hiding all the tools in pyREVIT. I've added already a custom extension called test tool. So if I go to test tool, I can see it's just in my documents. It's got an extension folder, a tab, which is going to be test tool tab, test tool panel, which you can see is here. And then I have two buttons, currently with no icons. And I'm just going to look at test tool 2. And we have two things. We have a bundle and we have a script. The bundle is using what's called a YAML file. It's not really a file I was familiar with before I used pyREVIT. I'm not sure exactly what else YAML files are used for. I'm sure they have their use, but effectively they are just providing some settings that the script will use. So this is why the tool is called testing 2. I've told it its title is testing 2, and I've said its tooltip is just testing. So I can hover over it and I get the properties of the YAML file. So this lets us sort of guide how our toolbar should look and display and behave. There are more complicated things we can do with it, such as changing the colors of buttons and also adding hyperlinks to hot links to help URLs that you can connect F1 help links to as well. So we'll just leave the YAML file. Let's actually build a quick tool. So I've set up just some areas we're going to build our tool using. Most of the time when you use pyREVIT, you're going to begin by importing some libraries from pyREVIT. So I'm going to say from pyREVIT, import Revit, which has some custom Revit commands, the Revit DB, which gives us access to the Revit API classes, scripts, which will allow us to stop our script, and forms. Now, if you've never seen pyREVIT, you're probably saying, how do you know those 4 things? Like, how do you even know that's how you begin a script? Well, you can look at the tools built by the author of pyREVIT, but of course you can also go to the Revit docs, so the pyREVIT docs. So I can look at the forms library or the script library or the Revit library. DB is a bit of a special one. It's a thing that pyREVIT has built into it that basically just says, I want to talk to the Revit API. So if I have a look at forms, I can see maybe I want to do an alert. And I can see I have a forms.alert. I pass a message, optional title, optional submessage. I can expand it, optional footer. Some of these are just default values. So by default, I see OK. I also don't see cancel, yes or no. I don't see a retry button. It is a warning by default. So you start to get hints about how you can use the various libraries that pyREVIT has built into it. So we are going to use some of these as we go. So the first thing I'm going to do is store the document to the Word doc or the variable doc. Now, you don't have to do this. You can say revit.doc every time you want to get the doc, which is actually using the Revit library to go and get the current document. But I just find it easier to store this to the Word doc because usually in most Python-based implementations of Revit, we just tend to store it to doc. It's just something all the Revit programmers do typically. It's pretty common. There are just habits you learn from the way other people program typically. So let's get all the sheets in the model. So we're going to use that filtered element collector. So because we're in pyREVIT, we're going to do db.filtered element collector. And this tells pyREVIT to actually go and get the class filtered element collector from the Revit API. So how do we actually know what that is? Well, let's go to Revit API docs. And let's look for the filtered element collector class. So from this, we can start to inspect the class. And this will provide us with both members, which includes constructors, methods, and properties. Typically, a constructor is how to create an object of that class. So we can see in this case, I'm going to construct it using a document. We can also target things like a visible view, and we can also search and filter a specific set of elements. So there are various ways you can construct these. We then have methods we can apply to these, which will do various things. So we can say, for example, that we want to take those elements and return them as element IDs. So we can transform this object using methods, and then we can also sometimes get properties. A filtered element collector doesn't really support properties. Let's just have a look at the view sheet class. So not the sheet class, the view sheet class. There are some confusing things like that in the Revit API behind the scenes. You know, in Revit, they're called sheets. In the API, they're called view sheets because they have a lot of things in common with views, and they actually technically are views by inheritance in the Revit API. So there's a lot of little things you learn over time like that that seem really strange at first, and then you start to get used to them and go, okay, I understand now. So you can see some properties here. For example, is the sheet a placeholder? What is the sheet number of the sheet? There's a lot more properties actually there behind the scenes. For example, we can ask it for a bounding box. We can do all sorts of things. We can ask for a category, an ID. So properties typically return a thing about the object in most cases. Okay, so let's just go back to our filtered element collector. And I'm just going to make sure that we're getting elements of class. And I'm just going to do DB so that we can reference the view sheet class. And I'll just pass them to elements. I don't believe you have to do 2 elements, but I'll do it anyway. So at this point, let's just print sheets. So we're going to use the print function in this case, which I believe will just send the objects to the console in pyREVIT. So if I hit this button, what's going to happen is pyREVIT's going to run this Python script for me and return the outcome. So in this case, we should get all our sheets. And of course, I've done something wrong. I've done of class, takes exactly here. I forgot to provide doc to filtered element collector. So pyREVIT also gives you progressive troubleshooting through its compiler as well. So we can see here it's helping us. It's told me in line 8 that there's a particular argument missing from of class. In this case, I've skipped providing an argument to this particular filtered element collector constructor. So now it should work. So you do get help from the program. And there we go. We can see all of our sheets. Now, obviously, they don't look very presentable. So what we could do is maybe say for S in sheets, print S dot sheet number, which is a property of the sheet. And it'll start to make more sense. And there we go. There's our sheet numbers. So we can start to see that we're able to start interrogating these elements. So what we want to do in this case is try to change the name to uppercase. So first of all, we're actually just going to ask the user if we want to do this. We've got some sheets, but are we sure we want to do uppercase? Maybe we don't want to go straight to this because maybe the user hit the button by accident. They didn't understand what the tool did. So we can say in this case that we're going to ask the user using a form. So from forms, I'll make an alert and I'll just say, are you sure you want to make names uppercase? And in this case, the title can just be, and we can say that yes, it's true, no, it's true, okay, it's false, and we'll leave a warning icon on there. If I hit the button now, it gets all the sheets, and then, no, it needs to be lowercase. There we go. So we should now get a little pop-up and there's a form from pyREVIT's forms library. If we say yes, it's going to pass the true variable to this, this object I've stored the form to. If not, it's going to store none, which is something that we can check for using an if statement. So I can say if not ask user, which means we rejected the form. I can just exit the script. And let's say after this point, I divide 5 by 0. I say no, everything's fine because we didn't go past that point. So we didn't divide by 0, no error. Obviously, if we say yes, it's going to go past that point and we should get an error. And there it is, we can't divide by 0. So we can see we're able to actually control the behavior of our scripts at a particular point in the code, which is really powerful. So creating exit conditions through code is actually really common once you start doing written code or creating alternate areas of an application to access under certain conditions. The final thing we'll do is actually create a function to actually make our sheets go upper. So we're going to make an upper name function applied to S. And maybe we'll just call this actually case change. And I'll say upper is equal to true by default. Otherwise, let's do lower. So I'll just do a try and accept just to be safe. So if something doesn't work in here, it just won't do anything. So I'll just try. In this case, to get the parameter, the sheet name in this case. So I'll do a longer method. If anyone's ever used the get parameter value by name, this is effectively what I'm going to be doing here using the Revit API. So I'm going to ask this sheet using the lookup parameter method for sheet name. Now I have the parameter as an object. I don't have the value of the parameter. I have the parameter as an actual object. Which is something that takes a bit of getting used to. There's lots of things that are objects you wouldn't think are objects in Revit, but a parameter of an element is actually another object in the Revit database. Let's get the value of the parameter. So in this case, I can say the parameter as a string is going to be the value. At this point, I should have the sheet name. And in this case, we can say if upper, which by default is true, then we can say case change is equal, in this case, to value parameter, and we're going to apply a Python method here, which is just upper, and that will change a string into uppercase. Otherwise, case change is going to be equal to, and you can probably guess what this will be, LP lower. And finally, there's no point in changing this parameter if it's exactly the same as the value it currently is. So we can say if the value of the parameter is not equal to case change, then we can try and change it. And what you can do with things in Python, it's a good habit to usually add comments and say, check if value needs to change. So if I use a hashtag, typically that will make a part of code that's not going to run, it's just there to annotate the code. And we know that if we did need to change the case, then we're going to take that parameter and we're going to set it to the change case value. Now, I'm not currently using a Revit transaction in this function. I'll use that after because we are making a modification to the Revit model, and we do need to signal to Revit that we are going to change part of the model in Revit itself. So we'll use another thing after this to make sure we can do that. So in this case, we're going to set the parameter value. And in this case, we also want to say, if this happens, I'm going to make my function return 1. This might seem a bit strange, but it will make sense when you see what I do with that. We can also say if we didn't need to change the value, return 0. And then if this didn't work for some reason, return 0. So the only thing we're going to return 1 on is if we successfully change the name of a sheet. So at this point, I'll just make this a little bit bigger. We'll try. There we go. So we're going to finish off our code. In this case, we're actually going to firstly say how many things have passed. Currently 0. And then we're going to say with Revit.transaction. So we're going to create a transaction to modify Revit. We're going to try to rename sheets. This is the name of our transaction in case we want to undo it. And then we say for each sheet in sheets, we're going to take pass count and raise it by the outcome of applying the upper name to it. So that's why we make 1s and 0s. We're effectively elevating our function by the outcome of trying to change its name. So we're skipping a few steps. So this is a bit of a programming trick there. And finally, we can print a message to the user saying how many sheets were changed. We can say string pass count plus, so we're adding strings together, and we can say sheet names updated. I believe at this point, this function should now work. So you can see at the moment, this home isn't uppercased. So if I run this function, are you sure you want to do it? Yes. Okay, of course, name, upper name is not defined. I think I need to, in this case, actually use the right function name, which in this case is this name. Sorry, sheet change case. Try again. Of course, 0 sheet names updated. Done something wrong here. Now I've just got to really quickly check what I've done wrong. The risk of live coding. There we go. Hopefully it's just that typo. I left out a lowercase r. If not, I'll show you some working tools after. Okay, so I'm going to sort of break a rule in programming here. I'm just going to actually stop using try and just see what's wrong. So I'm de-indenting in this case, and I'm just saying, I assume everything in here is going to be valid. It should work. And this should actually tell me what's going wrong. Change case is not defined, global name. So in this case, I'm still calling on case change or change case. I've called one case change and one change case. So it's just a variable naming issue, very basic error, just to prove that all of us make mistakes. I've still got one in there somewhere. Case change, change case. Someone can probably spot it at the moment. Yeah, there we go. Okay, so now it should work. Fingers crossed. There we go. You see it worked. One sheet now updated. There we go. We got there. We can very quickly just say, instead of that, and of course we could get the user to specify this argument. Let's just say false. Now we want to go to lowercase. And very quickly, whoops, that's the other one. I can run this in a different mode, and we can see that we're very quickly able to apply this in the other direction. So just a simple little tool. I might actually show you some proper toolbars very quickly. I know we've sort of went a little bit past the hour, but I might just show them quickly because I know that's always fun to see. And I do have permission to show these as well. So I'm going to add some more extensions here. The best place I find to store extensions is in app data typically. It's a very accessible location. So I'm just going to load up both pyREVIT, which is the company toolbar that I use, and guRoo, which is my custom toolbar. So you can have multiple extensions available at once. The more you have, obviously, the more time it's going to take to load. Some of them might start bumping into each other if they use hooks to detect the same things. So do be careful using multiple ones. Usually you need to know how they're behaving in order to use them together. Here's the one that we use at Architectus. So buried in here are all sorts of cool tools. I can't show every single tool. Some of them are very sensitive to the company, but generally there are some that I can show. So for example, I built a home button for Revit that takes me home. Now, every tool I run in this toolbar is going to be just a little bit slower than usual because I have a function built into my toolbar that reports the script used to my server that we run at work that actually goes and gives me a feedback of who's using the tools. So there's a little function that's basically hitting an error and proceeding on. So there's a little lag on each tool. Usually they're a little bit faster, but for example, we have wikis. We can access hyperlinks to websites. Most of these won't load because I'm not on the company server, of course, but they're shortcuts of people that we induct into the company typically. I have tools such as a nuke that basically goes and gets the model ready for an issue. It just tries to get rid of all the stuff we usually want to get rid of, hit the big red button, launch nuke, yes. And we just blow up the model and it's ready to go. So you can see I obviously just like automated a lot of stuff in just one step there. Let's go back before the nuke. So as well as this, I have some really interesting tools that sort of break the rules of Revit. For example, I have a tool called pre-filter. Let's say I want to get all the doors in this view. How would you usually do this? There's a few options. One is isolate category, get doors. Another one is, and a really bad way to do it is to do a big giant marquee all over the model, filter, grab my stuff I need. Now, most people do that, right? That's pretty common. A lot of people do that, sweep over the model, grab the things, deselect. If I use pre-select, I can say, I only want to get particular things. I only want to be able to select in this case, maybe let's say doors, walls, and windows. And I can make a filtered selection using a special class in the Revit API that pyREVIT has access to. In this case, an eye selection filter, if anyone knows it. I finish, and I've just formed a much faster, more efficient selection in my model. I can do things like select title blocks on sheets. Let's say I want to get all the title blocks on these sheets. Well, usually I wouldn't be able to do that, but I can build a tool that goes to the sheets and selects all the title blocks. And now from those 20 sheets, I should now gain access to their title blocks. So there's actually 2 title blocks in one of those sheets, I think. There's a custom title block. But so you can see you can sort of bend the rules a little bit in Revit. For example, I can build a bulk revisioning tool such as pyREVIT Sheets. And pyREVIT, this is a warning about large unstable interfaces that I sometimes put on tools to warn people that they shouldn't go scrolling too much around these tools because they might crash. But let's say we want to go and add revisions to those sheets. Well, pyREVIT actually has a function that says, oh, you have sheets selected. Should I just use those instead? If not, then it will let you pick. Otherwise, it will just run on the ones you have. Apply the revision. At the moment, they all have revisions on them of that revision, so they don't need to be revisioned, so it skips them. Let's down revision them. Let's go the other way. Cool. And there we go. We took the revisions off. Maybe we're going to print these sheets. Let's create a sheet set for the revision. Pick the revision. Makes a sheet set. Ready to print. So there's a lot of really custom tools you can make that sort of change the way Revit behaves a little bit. Do things that you wish you could do in Revit just to make things that little bit more efficient. Most of these tools are focused on those sorts of things. There are some other things I can't really show, like we have a batch printing tool in here that's pretty powerful. Similar to XREV, if you've ever used XREV, well, we don't need it. Sorry, XREV. We have view creation tools. For example, I can create plans by type and level. Isolate warnings in view. So for example, if I'm auditing my model, and I'll show a couple of these behind the scenes maybe as well, just because these are all written in Python, obviously. And then we have my warning elements in my view. Let's have a look at maybe one of these behind the scenes, such as the transfer wall type tool. So if I make a new project, everyone probably knows transfer project standards. Well, don't you wish you could just transfer a couple of things and not all the things? Well, you can. You can copy the elements from a background document using Python. So there we go, wall types. From my background document, I can just pick a few. I just want my cladding. Grab them all, copy them across. And I just got a few of them instead of all of them. There they are. So this tool, if I go behind the scenes, is a pretty interesting one, and I'm pretty sure I'm allowed to show this. It's not too sensitive. So in this case, I've just used a shortcut there, Alt and left click, which takes you to the folder that the actual script is in. Now this script is going to look very, very simple. Look at that. That's all it is. How simple is that? It imports a library. It imports a library, reports to the server that the tool has been run, and then uses a custom function. So it looks simple. Let's go behind the scenes. What is copy utilities? Well, pyREVIT actually lets you build your own libraries. So we have copy utilities. Well, that looks a bit more complicated, doesn't it? So in this case, the script that I was running uses copy by class, which is a function that I programmed. Now, I'm not using classes in this library, which isn't always best practice. So if anyone knows Python well, you know I'm not really following best practice in this particular library. So do forgive me, but here we go. Now we can see this is what the copy by class is actually doing. It's running in some modes, using some user messages. But the great thing about that is that every single tool that I use that does this, whether it's ceilings, roofs, floors, is really just calling on the same function. I've written my code in one place. It's a bit like using a custom package. So if anyone is already using pyREVIT, I highly encourage you to look into libraries. Also, sometimes using custom classes, that can be really useful because eventually your toolbar can just get too big for its own good. There's too much code that's copied in multiple places. A library is a fantastic way to sort of consolidate it. I might quickly show guRoo as well. So guRoo is a smaller selection. Some of the tools are similar, some are almost the same because, you know, everyone has one, like an add revision to sheet tool. Everyone's got one. You know, they're pretty easy to write if you know Python. And the Revit API, there's a home button here too because it's a pretty basic tool. But this has something like a bulk exporter in this case for PDFs. So this uses the exporter, whereas we use the plotter where I work instead. I think there's no sheets in this model, which probably doesn't help. If I go back to this model and I run guRoo, export sheets to PDF. This is obviously only going to work in 2022 and beyond when they added the exporter. And it'll go and start pumping out exported sheets with a predefined naming rule. And there they are. They start going. You can see I'm using loading bars, which are a feature in pyREVIT as well. You can put things into loading bars in order to make a more stable interface for the user. And it's automatically just by default known to start printing to a particular folder because I've written the tool to work that way. So rather than forcing the user to go and navigate to a directory and take minutes to do it, it just says, just go to C drive, just go to my documents, automatically build a path. So that's just some examples of some tools I've built in pyREVIT. But I guess the point that I want to show is it really does free you up from being limited by the tools. As long as the API gives you access to something you want to automate, it's definitely possible. There are some more complicated tools I can't run through here, but they tie very closely to company process. So things the company wants Revit to do to suit them rather than doing things to suit Revit. So automating is usually a really good way to do that. So I do encourage any company that's maybe over, say, 30 people, even if you're smaller than 30 people and you have the passion, do it. Explore automation. Start with Dynamo, build your way up to pyREVIT, consider add-ins, consider spec, all sorts of ways to automate and streamline and interoperate. So that's sort of just the end of a very quick and slightly eventful live demo. Didn't go too badly. So I guess I do like to remind people that pyREVIT is technically free. It is technically open source. Well, it is open source, so it is worth supporting. At the moment, Hassan's probably pulling in about 750 Australian dollars a month, which seems a lot in some places in the world, but in a Western economy, it's not much these days. Unfortunately, it's about a week of rent, maybe not even a week of rent. So he does definitely need all the support he can get. He gets a lot of support from the community, so that is another way you can support pyREVIT, just by being involved on the forums or helping people promote the tools. My support is I try to promote pyREVIT and show how it can be used. And I also, I'm one of the patrons on there as well. Not everyone can afford to be a patron, so I'm not saying give your money, but at least give your interest and your time if you're using these tools already, because we really want these obviously to be tools that last and tools that have people available to develop them in the future. So I guess thank you for listening. That sort of concludes my presentation. I hope there's been some interesting things in there for people to learn from, people to be inspired by, some little tips and tricks if you're already using Python. And if you haven't even started your automation journey, hopefully it's given you some inspiration to potentially jump into Dynamo or just consider what this could do at your company or in your daily life. It's definitely changed my career a lot. So thank you. And I guess I welcome any questions from the audience, and even Peter, if you've got any. But yeah, happy to switch over to Q&A.
Thank you very much about your presentation and everything that you've shared. So I encourage anyone who has any questions to ask them and to see.
There's a couple in the chat.
Yeah, so
oh, thanks. I saw you were trying to give me tips on the programming issues.
No worries.
Appreciate that. Thank you. So I see the first one from Eric. I think Eric is still here. Yes. So yep, they ask if I have websites, GitHub repos, videos. Yes, definitely. So I'll very quickly show some resources that can help you. I'll just share my screen again. So if I go to the internet, the first one is my GitHub. Anyone that does programming, I do recommend get to GitHub. It's a great way to just share things. I have Dynamo scripts. I have my Dynamo custom package there, as well as on the package manager. If you go to the repositories, you'll find somewhere in here is guRoo. Where is it? It's usually there. Oh, there it is at the top. This is my pyREVIT toolbar. All the files are there. It has an installation guide. It even has a little wiki down the back somewhere that sort of has some images and descriptions of some of the tools. So that's one place that obviously can help. I have a YouTube channel, the Aussie BIM guRoo. So easy to find. People can probably figure out my music taste by looking at that. I like heavy metal. So in this case, my YouTube channel, which has about 350 videos sorted into playlists, typically by technology. Occasionally I play Super Nintendo for fun. But we have Rhino inside, Python, Python 101, webinars, Revit, Dynamo, Python and Dynamo. I also have a course website which has some free resources on it that will probably help. If your company is looking for BIM content, there's some paid content on there as well. I do support companies with their family needs. So I have a paid course in Dynamo, but it's a very thorough one. But then I also have free models, which have some support content. So I have this basic sample project. I have a healthcare project, and I have an apartment project, a very simple one, and they're all free. I do have a paid model, but that's usually more for people doing training with models. So hopefully they help. I recommend looking at the YouTube channels for Revit Pure and the Revit Kid. If you're not familiar with them, I'm pretty sure most of us have probably come across them before. They're very popular. Revit Pure is a great channel. Nicholas Cattelia manages that one. And I think most of us would probably know the Revit Kid, or Jeffrey A. Pinheiro. He's a really cool guy. I've been lucky to be on his show a couple of times. He actually inspired me to start YouTube. So he's the OG, one of the original gangsters in the space. Dynamo Python Primer is a great place to learn Python for Dynamo by Oliver Green. And this has a step-by-step guide on learning Python in Dynamo. And there's other resources around, but hopefully this loads. Hopefully it's still there. I always worry some of these pages might not last the test of time, but I assume it's probably still there. It's probably having a loading issue. But that's some resources that I recommend. There it is. So that sort of teaches you the fundamentals. And probably the best one of all those is just forums, Dynamo forums. Way too many people don't participate in the forums, and that's actually the best place to learn and troubleshoot all sorts of issues. I'm a moderator on the forum with lots of other people, but effectively we just solve problems that people bring to the forums. We don't do people's work for them, but we can give a lot of assistance and advice to people having challenges with Dynamo. pyREVIT has a slightly less active forum, and there's a Revit forum, of course, as well. So hopefully that's a good variety of resources that hopefully help people. Time is a good resource too. It's going to take a while to learn these things. Don't rush. That's probably my biggest advice for anything. The more you skip, the less you learn, is usually what I tell people. Someone asked about recording, which we will have. And you've answered, thank you. AI for Revit. Actually, I might show this. This is probably a good one. AI for Revit's a little bit of a joke in my toolbar. So I don't know if anyone knows the internet phenomenon of Rick rolling people by playing Rick Astley, Never Gonna Give You Up. If I hit AI for Revit, I get this. I get rickrolled. So there you go. That's what AI for Revit does. So I think AI is very interesting, but I think it's a very new field, and people are trying to do too much with it too quickly. So it's a bit of a joke to my company saying, you know, Revit AI is not quite here yet. AI is an interesting topic. Yeah, I agree. That's I think you said that, Peter, didn't you? Yeah. Yeah, definitely an interesting field. Lots of cool things going on. If anyone's looking for an example, maybe look into Veras by Evolve Lab. It's an image generation app from Revit using static diffusion, I think it's called, or stable diffusion as the algorithm that creates the images. Can you change IronPython to CPython for pyREVIT? Yes. Someone's asked, I think Sylvia asked that. I believe I should be able to find a very quick example. Just stop me if I'm talking too much too, Peter. I'm just sort of breezing through the questions one by one.
No, it's really helpful. So yeah. So
CPython 3 in pyREVIT. This is how I solve 90% of my programming problems. Usually there's someone that's made a thread out there for it or a question about it. Usually you have to specify it in the header of your code. There you go. That's how you go to Python 3. So you put that at the very top of your Python script, and at that point, you're instead using Python 3 as your interpreter, which gives you access to pandas, NumPy, SciPy, scikit-learn, all sorts of libraries that Python 3 is really able to access, which Python 2 doesn't have ability to access, which is pretty big, especially if you're doing machine learning, which might be why the question was there.
Actually, we didn't saw your screen. You were sharing.
Oh, sorry. I'll try sharing again.
So we saw only the code.
Oh, I went to the code screen. So that's effectively what you put at the top of your code. Hashtag #! Python 3. And that creates sort of a special comment for pyREVIT to say, oh, I'm using Python 3 instead. And it brings its own, I think its own build of Python 3 with it. That enables it to run libraries like pandas, NumPy, SciPy, scikit-learn, matplotlib. I think matplotlib might be in IronPython as well, but it gives you access to a lot more abstract libraries. So hopefully that's a useful one. I think otherwise we've covered that. Someone like the Rick hack, good. So I think otherwise that's it. I guess, is there any other questions that people have? Peter, one last technical question. How many people as a percentage use Dynamo or Python in your architectural practice? A lot less than I wish is the answer. But out of 400 people, about maybe 45% of them are using BIM regularly. And of that 45%, I would estimate about 5% of not even 5% of the whole company, probably 3%, I would say, are probably able to build Dynamo scripts. About 50% of that, roughly 50% of the company, so a quarter of the company, is probably able to run Dynamo scripts, and about 30% of the company probably does run Dynamo scripts regularly based on my statistics that I collect from my toolbars. pyREVIT, I found about maybe slightly more would run pyREVIT because they're more comfortable typically running the tools. I think I'd estimate maybe about 60% of the Revit users have engaged with the pyREVIT tools, and it's growing as I train more people in the toolbar. So I found it's definitely helped. So it's a good question, Vladimir, and a fair one too. I think anyone that builds tools for a company has to be painfully aware of the adoption rate of the tools they build to justify building them in the first place, because otherwise eventually a manager is going to question and say, where's the business case for that? Did we actually, make sure that was worth doing? And at a large company, you have to do that. So pyREVIT had a business case before I actually got to do it.
Yeah, thank you, Gavin. That was really nice presentation, and thank you for that answer as well. To be honest, I'm asking this question because obviously you don't need everyone to be involved in Dynamo, and you can't really achieve that. I mean, I personally tried it a couple of years ago, and I thought that's not for me. I prefer just to do architecture. But I'm lucky enough to work in a big company where we do have a BIM team, and they, by request, they can do whatever we want them to, they can create scripts for us. But if you work in a smaller practice where you have, let's say, 10 people, you might not have anyone using Dynamo. So I guess it's a good opportunity to have like an external consultant or someone just to help you with that.
Precisely, yeah. Yeah, when I consulted, I actually did have some of my biggest clients were actually firms that didn't have the internal capability or time, or didn't have the time to learn Dynamo from the ground up, and said, we just want someone to come in at an expert level and just help us out. Some of them actually, once they saw what I built, said, actually, we want to learn this, we want to own this. And it inspired them to build the capability. Other ones said, this is awesome, but we would never in a million years be able to support this in-house. We're 6 people, 7 people. So I totally agree that eventually external consultancy makes more sense.
Is that something you do, or?
I did. Occasionally I do take it on, but not at scale, because I guess I work full-time with Architectus now. So whilst I did have a lot of clients of this nature, I found Dynamo scripting didn't usually become a repeat service. Usually they either became comfortable enough to do it themselves, which is great because I'm only one person, so I don't want to have those clients forever. Or it was just too irregular when they needed something. It was like, we need something now. And then 5 months later, a different case comes up, and so it was less predictable as a business model. But there are definitely consultancies out there that still deliver those types of services or build add-ins, like guRoo, for example, builds add-ins for companies. That's why all their tools are free. It's marketing. So there's lots of groups out there for sure.
Thank you.
You're welcome. Yeah, thanks for coming. Cool. Yeah, I don't know if you had any questions, Peter, based on what you've seen. I guess you understand a lot of what I'm showing. So
yeah, I think your presentation was really informative, and you covered a lot of things that were very interesting. Yeah, so I don't think that there are more questions. I don't see anybody in the chat, so thank you again.
If anyone does want to reach out to me, I can be reached on LinkedIn. Usually I'll respond to, that's how Peter initially engaged me, found me through LinkedIn, and I wrote back eventually. I was very busy, so it took a while. Sorry about that. But I can also be reached through the comments on YouTube on my channel. I respond to every comment eventually. And Twitter, I'm on Twitter as the BIM Guru and Aussie BIM Guru. So yeah, feel free to reach out. I like to say the only dumb question is the one you don't ask. So even if you think it's a silly question, ask it. It's worth it. Yeah, cool. Well, thank you for having me on board. I've really enjoyed presenting, and I'm glad to have shared some knowledge with another area of the world. It's great. Yeah.
Really nice to have you, and I just want to tell everybody that there will be a full recording available on YouTube, on our YouTube channel, where we will try to add also all the, or at least a lot of the links that Gavin pointed out, different sources of information about pyREVIT, Python, Revit API, and other things for your convenience to have direct links there, and also Gavin's coordinates there in case you want to contact him directly. So yeah, thank you everybody for joining us, and see you next time. Thank you.
Thank you. Have a good day, everyone.
Bye bye.
Thanks, Peter. Talk later. Thank you. Bye.
Bye.
Bye-bye.